It's week 44 of 2022. This is Talking Science, catching you up on the month's biggest stories with Dr. Brad Tucker. Australia signs on to a Japanese sample return mission. In 2029, we'll have the first ever samples from Phobos. The largest massive impact crater in 16 years has been found on Mars. And speaking of large, meet 2022 AP7, an asteroid ranking in the top 5% of all-time biggest, potentially hazardous objects, and it could get in Earth's way in the next few hundred years.
This is Trekzone's Talkin' Science.
Your monthly reminder, the Trekzone membership is available via the join button under each video on YouTube or via the trek.zone/support. Plus Trekzone's on Twitter, Facebook, Instagram, and your favourite podcast feed. Find us everywhere, like, follow and subscribe. We now have Super Thanks enabled on the channel as well. It's the ability to contribute without becoming a member. Support us make more great content. Brad Tucker is here. He's on social media at btucker22 on Twitter, Dr. Brad Tucker on Facebook. Brad, welcome back to Trekzone, my friend. First up,
How's
a quick mention of very well, speeding through everything. A quick mention of tonight's blood moon, if you will, sir.
Yeah, look, if you're in roughly a third of the world, you'll see a blood moon, which is always convenient. Visible in Australia, New Zealand, Asia, most of the Americas. Sorry, Europe, you miss out, but you know you had a partial solar eclipse earlier, so I don't feel too bad for you. Yes, happening with the moon passing into the Earth's shadow, and you get this red color because a little bit of sunlight skims the Earth's atmosphere, goes off into space and lights up the moon. So it's a really cool phenomenon. You don't need special equipment. You just need to go outside and look. You can check online, places like timeanddate.com and things like that. You can enter your location and find your exact timing of it.
And also, you mentioned no special equipment required. I think with this one, we need super yachts and to be in the middle of the Pacific Ocean to get the absolute best position. Is that about right?
That's the absolute best position, but really, as long as you're somewhat covered, you will mostly be okay. New Zealand is pretty well centered, but for the most part, you'll have a fairly good view of it.
All right, well, let's get into the show. The 9th Chinese space station-related mission since April last year took flight last month, completing their ambitious station in orbit, Brad.
Yeah, we mentioned when they said, hey, they were going to try and finish this by the end of the year, and look, it was an ambitious timeline, and they've managed it. This was that final main part of getting up, that last module, as you said. There's still some work to do to complete it, but they already have an astronaut, or a taikonaut crew rather, up there on their space station, the Tiangong space station, to complete it. So it will, unless something happens, be operational by the end of the year. In fact, with a little bit of room to spare. So, you know, they, as we've mentioned before, are powering through in some of these areas.
We now know who will be joining NASA's Unidentified Aerial Phenomena study, the space agency announcing the team a couple of weeks ago, Brad.
They did, and you know, it was a variety of people from across the board and expertise. A few close colleagues I know, Fed Bianco, who works on supernova like me, but also does some things into urban planning. Nadia Drake, who's actually a microbiologist by training, but writes regularly for National Geographic, and is the daughter of Frank Drake, who came up with the original Drake equation for times of life, but also ex-military, ex-NASA pilot Scott Kelly, the famous first American to spend about a year in space, and expertise all in between. So a very diverse panel in terms of scientific background and technical expertise.
Let's keep moving on the show. The Australian Space Agency has agreed to collaborate on the next Japanese sample return mission, Brad. The precious cargo will land in South Australia, just like Hayabusa 2 and Hayabusa 1 at the end of this decade, and the capsule will contain samples from a place we haven't been to yet.
That's right. You know, the moons of Mars are very different in a lot of ways than our moon. They're tiny. Our moon is a little bit smaller than Australia. Those moons are smaller than a city. They're only 16 and 25 kilometers wide. We think they're captured asteroids. They orbit so close to Mars that they're actually closer than our geosynchronous satellites around the Earth. They are very close. And so because of this, the idea is, well, we don't really know a lot about these moons. let's go and study them in detail and land and grab samples. But also because of how close they are, there's a belief there may be some rocks and samples of meteorites that have crashed into Mars, flown out, been ejected out, and actually landed on those moons, so that you could potentially grab some Mars rocks as well, in addition to the rocks of the moons themselves. So very unique, very ambitious, and an exciting mission as part of this growing cooperation between JAXA and Australia.
Now, with the timeline, you can tell JAXA have great confidence, the Japanese Space Agency, and experience as well in this. We know that they've done Hayabusa 2 as well. They're planning on launching MMX, launching September 2024, landing on Phobos in August 2025, and returning to Earth in July 2029. It's almost becoming the start of a decade-long tradition. Hayabusa in 2010, Hayabusa 2 in 2020, and now 2029 for this MMX mission, Brad.
That's right. Yeah, and this is kind of the exciting thing, is you can make these missions kind of turning them out quite regularly. And the hardest part to some degree here is just how long it takes to get to Mars. These timings are, because it'll take 6 months alone-ish to get to Mars, and then you have to wait for the orbits to line up back. There will also be other countries that have cooperated, just as Hayabusa 2. CNES and DLR, the French and German space agencies, will be building a probe to land, a rover to land on Phobos, the moon as well, just as they landed some craft on Ryugu with Hayabusa 2. They're also working with Japanese television to produce the first 8K television images of the moons of Mars and Mars itself. So, our views of Mars are going to get a whole lot crisper coming there. And so these are the cool things that you can do just by the sheer amount of cooperation, working together. And so this is definitely a great mission for Australia to be a part of.
I'm just thinking of our friends at Tidbinbilla, Glenn Nagel and everyone having to process that 8K data as it beams down. That is going to be a huge file for them to download and have loss prevention on.
Yeah, so I think people may be retiring towards the end of the decade, so they don't have to deal with that. I don't know. But yes, no, there's a lot of work that will happen as part of this. And as you said, broadly across lots of sectors in Australia. Some of these samples, as with Hayabusa 2 from the Mars mission, will stay in Australia to be studied by Australian scientists as well, with both places Phil Bland and Curtin and Trevor Ireland at University of Queensland being involved in these past and future missions. So really exciting opportunities as well for the science to evolve and happen, and Australia is part of it.
Now, we've spent a long time looking at Mars, exploring the Red Planet surface, orbiting, roving, and even droning. But this will be the first mission to a satellite of Mars. What are the burning questions right now that the Martian Moon's Exploration, MMX, hopes to answer?
So there's a few, right? There is, exactly what and how are these asteroids made up of. We believe they're captured asteroids, but we're not exactly sure. Is there any sign of its history? There's some models that suggest the moons of Mars are slowly migrating towards Mars, and may actually, and probably will, due to its gravity, break up in 20 to 40 million years. And as they break up, they'll kind of spread this huge area around as a ring almost. And some models have suggested that gravity has actually brought that back together to form almost a cyclical moon, potentially. So a little bit about their history, the history then of Mars itself. If they can find Mars rocks, then that could be signs of massive bombardment by meteorites on the planet itself. So a huge range of different things there. And, we've spent a lot of things of rovers landing on Mars and studying them and samples of getting it back, but the moons have been neglected. And so if you want to understand the entire planetary system, just as you need to study our moon to help understand Earth, you need to do it with Phobos and Deimos as well.
And for a long time, the planets of our solar system were the focus. Now we seem to be shifting to the moons, planning underway for Titan and Io missions, and now Phobos. In general, as overall, what can the moons of the planets tell us? As you say, studying them helps us to understand the planets, but kind of, I guess, what are we looking for when we're studying these moons?
Yeah, there's a lot of interesting debate about the formation of moons as well. There seems to be multiple paths to some degree of how a moon can turn into a moon. Migration, moving towards it, being captured, being formed from a collision, or form completely different mechanisms like Jupiter and Saturn, which appear to be, their moons are larger than in some cases Mercury, and they have atmospheres. And so it's that interesting dynamic between the moon and the planet itself. And then obviously, is there signs of life in some of these places? So it's, there's 120 something moons, I think, or so in our, maybe 130 in our solar system. That's more than the 8 planets we have. So that means there's a lot of bodies which are all very, very different. And then why also does Mars have moons at all? Mercury and Venus do not. Earth does, and Mars does as well. And again, Mars's moons and our moon appear to have very different past histories. So that tells you a lot about the planet itself. Does it give insight into the tilt of Mars? Just as studying our moon gives insight into the tilt of Earth. So there's a lot of these different things that really start to build up the picture, both of potential exploration, the idea of life and habitability, and the creation of the systems themselves.
Well, just before Christmas last year, NASA's InSight spacecraft had a front row seat to a pretty spectacular sight. It's staying with Mars, but moving on to our next story. It's seismometers measuring seismic waves as they reverberated across the planet. Brad, what caused that?
Yeah, and this was from a fairly massive meteorite impact. It left a crater about 150 meters wide, visible on the planet. And as you said, a seismic wave traveled all around the planet and detected by InSight, which was in the different hemisphere. It was in the southern hemisphere, as opposed to the strike, which happened in the northern hemisphere. And this is actually something the scientists on this team have been waiting for. InSight has been designed to measure waves, seismic waves and activity underneath the surface of Mars. They've detected Mars quakes. They've detected some meteorite impacts, but very small ones. They were trying to hope to discover a wave that traveled from the other hemisphere and all around, so they can actually study more of the underneath of the surface of the planet as a whole. As that wave travels around, you can monitor what's going on. So it's definitely a well-earned Christmas gift for all the team.
And scattered around the impact crater that measured 150 meters wide were blocks of water ice excavated by the force of that crashing meteorite. And that was a pretty special find because it's closer to the equator than anything previously discovered.
That's right. We found signs of ice slightly underneath the surface before. Obviously, there's carbon dioxide and other ice at the poles. As you said, not only was this deep, but it was very far away in its location. And this, again, goes to the geology of the planet. If you look at Mars, the northern hemisphere of Mars is very different from the southern hemisphere. The northern hemisphere is low-lying, believed to be volcanic lands. The southern hemisphere is highlands bombarded by meteorites, and also some volcanoes. So very different geology. If you look at Earth, we're fairly even hemisphere-wise. It's very different on Mars. And so there's been a question of exactly, is this the case? Is the composition underneath the different? Is the ice similar near the equator and far away from the equator and between hemispheres? So it was a unique way of probing a very different part of the planet that we haven't been before, but also that the probe wasn't and couldn't. It doesn't move. It's just sitting there. So it was a great opportunity to get a lot more, insight into Mars.
Now, I was reading a little bit about the Mars dichotomy mystery that you're alluding to there. Why is the North so different to the South? And the Mars Reconnaissance Orbiter also traced the source of another seismic wave a few months earlier. That was to a 130-meter wide impact crater, about 7,500 kilometers away from InSight. And these two events are helping to shed light on the internal structure, answer that dichotomy mystery as to why North and South are so different, aren't they?
That's right, because they can see how the waves move around, and depending on the composition, you can see how the wave moves. Does it move through different pockets in the hemisphere, either longitudinally around or latitudinally up and down? And then get insight into what's measured locally. Because it does appear to be the case that it's a fairly smooth, uniform northern hemisphere, more from volcanic flows almost. Where in the southern hemisphere, it's very clumpy and more clay-like. So the densities in the waves move slightly differently. So as you said, by having these two move around the planet, you got very interesting data multiple times, again, which is A, what you want, and B, making sure there was nothing based on the location it landed, the impact itself, and again, a bit of that latitudinal position on Mars. And this was one of the big science goals of InSight, was to try and do this. They just had to wait for 3 years to get their data.
And this could all add to mounting evidence that Mars is still volcanically active. You're sort of alluding to it there a little bit, but yeah, we could actually still have an active red planet.
And that was always the case, is not just, what are these layers like? How deep are the layers? These have been some of the other questions that InSight has been studying. But yes, is it active underneath the surface? And you get insight into that based on the quakes they measure. What are the nature of the quakes? Because there's different types of waves that move due to seismic activity. And is there signs that it could still be volcanically active? We know there's a lot of volcanoes on Mars, and they're more akin to hotspot volcanoes, like you would get, say, in Hawaii or Tonga, where you get a hotspot that comes up underneath the ocean. Different than some of the other volcanic activity in the other solar system. So you can look at places like Io and other moons that have slightly different mechanisms, and some that are similar. And then this is also useful for trying to even understand a place like Venus. We don't understand a lot about Venus. It has this runaway greenhouse. There's a lot of debate about whether it had volcanism in the past. Is it still active or not? So all of, by studying Mars, Earth, and Venus, you get different extremes of the problem. And that's why we're interested in this. You can kind of see, is it, if Earth really is in the middle, where we use it as the base point, is it more extreme one way or the other? And by having such different planets between Venus and Mars, you can really get that data, which is also why a lot of people are talking more and more about studying Venus as well.
Well, just time to dive into the planet-killing asteroid on the way to us, Brad. 2022 AP7. It's been found. It's on the other side of the sun, and it's one of a trio that's been discovered.
We know there are asteroids that we're missing. We can kind of measure it through a variety of mechanisms, and we know that we're incomplete. And we're incomplete based on sizes. So we know on the tiny ones, we don't know a lot of them. On the really, really big ones, we're fairly complete. The more medium-sized ones, the couple of kilometers to hundreds of meters, we know, again, is somewhere in between. And part of this has to do with our visibility of finding them. We generally look away from the sun because that means we have lots of nighttime and we can see these objects moving. But we also know that objects can exist near the sun as viewed from us. And if they're kind of always hanging out in that same spot, they can kind of be in your permanent blind spot. We kind of usually imagine that they'll eventually move around the sun just like we do, and at some point we'll be able to see them. But if they're always kind of in our blind spot, we will always miss them. And that's the case of this. And in order to see this, they had to look just around twilight time. So just either right before the sun rises in the morning or sets in the evening, where the objects are fairly close to the sun, but you can just make them out. And that's where these three were discovered, in this proverbial space blind spot. And as it turns out, at least one of them is quite sizable. And one of them is definitely of the class of these Earth-crossing asteroids. It regularly, in its orbit around the sun, crosses the path of Earth, which is obviously what you want to monitor, because those are the ones that you worry about.
Yeah, absolutely. Well, we should declare that the risk right now is low, but in the centuries to come, we'll likely need to have perfected the lessons learned from the recent DART mission.
Because it's kind of slowly in its movement, still in that blind spot, it's going to stay out of our way for, as you said, for centuries. We also don't have a lot of data on it because it was only recently discovered. Now that we know what to look for, you can kind of keep track of it, but it's still hard to see always being near the sun. The example is, if you ever try and look at the planet Mercury with your own eyes, it is visible, but it's so close to the sun with respect to Earth, it's really hard to see. You only have a small window of seeing it every night. Venus is a lot easier to see. Places like Jupiter and Saturn, you can see quite a lot. And this is the case with this asteroid. You will always have a small visible window of getting data, better measuring that orbit. And as you said, as of now, it doesn't pose any risk for centuries, but it is one that probably will pose a risk in the future. And because of its size at roughly 1 to 2.5 kilometers, can do sizable damage if it were to hit the Earth. It's much bigger than the one that DART was tested on by a large fraction. But, that's the whole point of that DART mission, was to see, at the very least, if it works, then, all right, well, maybe we need 5 darts or 10 darts. But at least one will do a little bit, then you can repeatedly do it and do it more, or you can change the nature of the mission as well. So this is part of this doing in tandem, is you have to find the asteroids and you have to find a plan what to do about the asteroids. It's no good just finding them and not having a plan. And it's also not good having a plan, but not finding them, because if you don't know them ahead of time, you're out of luck. So, it may take that we need to start nudging it 100 years in advance to save Earth. So you have to know, A, how much you'll need to plan it by, and you have to find it a couple hundred years in the future in order to plan it. So it seems very long term, but this is the way it has to work in space.
Well, Scott Shepard from the Carnegie Institution for Science in Washington led the team that made this discovery. He said in his submission to the Astronomical Journal that they expect to find more in the next year or two. Now, it's something that I still struggle sometimes with, Brad, to wrap my head around, is that asteroids in our solar system, they're not just in a neat bunch around Mars and Jupiter. So how worried should we be about a potential planet killer out there going unnoticed?
I mean, there's always a bit of a worry, but, we do know of very clear parts where these asteroids hang out. And we know kind of the groupings of them, the populations. And so this is also the helpful thing. If you find 3, clearly there's a bit of a population out there. So you can keep monitoring that area throughout the year to keep finding them. And as you said, Scott and his team will be doing this. And this is using just telescopes that we use to find supernova in Chile. And again, this is kind of the cooperation of these international facilities. The sky is too bright for us to look for supernova and black holes and other things, but it's not too late for them to do their work to find these asteroids. So this is where a lot of these facilities in terms of their operation have changed to benefit all this. So instead of staring at it all night, where, all right, during the middle of the night, we probably don't need to find asteroids and we're actually going to find them looking for supernova anyways, let them be dedicated to finding asteroids then, and then we can do our work. And that maximizes the operation of the telescope, maximizes the science and sharing resources. And this is exactly how this has happened. So it's a really great way of doing science these days, is collaborative, different science cases come together to do joint facilities. And so even though we know there's more asteroids out there, we're getting more clever and we're building more telescopes and systems to find them better. And this is where, we're headed. And part of this has to be concerted effort. And lately the problem has been no one has really felt it was their responsibility to do this. People like Scott has also been studying comets and TNOs. That's been a lot of his work. So this was kind of a unique chance as part of his work to find these things. And so you don't have to build a dedicated facility. In some cases you do, but you can do the sharing that maximizes return on discovery.
And I guess in terms of risk and worry and stuff like that, we should probably look at our low Earth orbit first with all the space junk that's around that. And maybe if there's an asteroid that swings by, it might just suck up some of those and we won't have such a big orbital problem.
Yeah, look, there's a variety of issues. In generally speaking, people are not that worried about asteroids, right? We do know of them. We do know of the ones. And again, yes, we don't know of all the small ones, but the small ones aren't going to do that much damage if it hits Earth. The big ones, the really big ones, we're pretty good at finding. Yes, we need to work better on the medium ones, but we do know we can find them well ahead of time. And so this is all part of the work and all part of the plan, and why that DART mission was both important, but also why there's other issues that you have to deal with. Solar storms as well. There's a number of them. So not things you necessarily have to lose sleep over, but things we do have to study and work on, just as we study weather and monitor earthquakes on Earth. You have to do this in space as well.
Absolutely, and train up the next generation of oil riggers.
That's right.
I love it, Brad. It is great to pick apart the past few weeks with you. We've been doing it the last couple of months. 2 more episodes to go before the end of the year. Absolutely incredible. 2022 has flown.
It's been busy, but it's nearing the end. Gearing up for an even busier 2023.
Absolutely, Brad. We'll catch you at the start of December.
Thanks.